If no forces other than gravity act on my body during my trip up and back down, then my body's total mechanical energy will not change. However, the energy of my body can change forms. Initially, my body has a lot of kinetic energy because my base has given me a large upward velocity. In this case, the total energy is conserved because it doesn't change. However, as my body moves upwards, it slows down as my initial kinetic energy is transformed into potential energy. Eventually, all of the kinetic energy will become potential energy, and my body will stop momentarily. My body has finally reached the highest point. After this, I will turn around and fall back to my base, as all the potential energy I had at the highest point is transformed back into kinetic energy as it falls to the ground, or in this case to my base. When remembering the formula of the kinetic energy and connect it to the picture, we can analyze that the kinetic energy is dependent to the mass and velocity and can be manipulated because it isn't constant. So at the same velocity, if my mass is 40 kilograms, then the Ki, or the kinetic energy, would be less than the kinetic energy of my base throwing a larger mass right now when I am 44 kilograms. While for the potential energy is majorly determined by the height of an object. In this case, my body possesses potential energy because of the altitude or height of my body on the peak of the throw. When we compare both pictures, we can analyze that my body possesses a different amount of potential energy, and based on the calculation, a greater mass leads to a greater potential energy. This is a picture of me pushing a rollerboard during my trip. This correlates to Newton's first law of motion that states that an object at rest stays at rest unless there's an unbalanced force that acts upon it. Here, the rollerboard isn't moving at all, but when I locate my hand and give some force upon it, it moves, although it moves a little bit, and then it stops because there's an unbalanced force, and this unbalanced force is called friction. This picture represents a moment where I threw a cotton back then and a bag right now. As we know, Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to its mass. Acceleration of an object depends on two variables, the force and the mass. In this picture, I can analyze the difference of acceleration based on the mass. We can logically understand that because the mass of the cotton and bag is different, each of them will travel a different distance and at a different speed when it is thrown with the same force. Or, another case can be analyzed that if I throw the cotton 2 times with a different force, it will also travel at a different speed and distance as well. Now here is a fun picture of me and my friends running at the beach shore. This correlates with Newton's third law of motion because it proves the concept of action and reaction. Newton's third law simply states that for every action, there is an equal and opposite reaction. So when two objects interact, the forces they impart from each other will be equal in magnitude and opposite in direction. This is relevant to walking and running because when you put your foot on the ground, you are applying a force to it. In doing this, the ground also actually applies an equal force onto your foot in the opposite direction, pushing you forward. Now, from this picture, I can analyze how whenever me and my friend's feet hit the ground when we are running, the ground hits our feet with an equal and opposite force. What I felt on my foot is the reaction of the ground pushing me forwards. So, in a simple visualization, my feet is pushing the sand backwards and the sand is pushing my feet forwards. Last but not least is a picture of me riding a rope adventure back then. I can analyze the free body diagram of this picture. Just like an example we did from the previous workshop, this picture represents a free body diagram similar to a hanging chandelier or traffic light. There are 3 tensions from the rope and a gravitational force pulling my body towards Earth. However, there is no normal force because there is no table or ground. Now, to answer the focus question, which is asking, how can humans analyze transformation based on physics concepts and laws in day-to-day activities? By looking around our surroundings, we can see lots of physics happening. There is also lots of physics happening which our own senses cannot detect. In this case, our main topic this term is used in mostly all of our days, because every activity we do includes motion and force. Transformation occurs in our day-to-day life activities, and it is especially common in physics, just like the transformation of energy. The field of physics, like many others, helps shape the world to what and how it is now. Also, to answer our big question, which is asking, why do visionary leaders adapt? We as students must be able to adapt to different physics concepts and laws in order to be able to analyze the concepts applied in different real-life situations. Analyzing the pictures I have just explained requires adaptation with my logic and the concept of motion and force. So this is one trait of a leader that has a creative and flexible vision of analyzing concepts in a real-life situation.